Okay, so slope fields that represent the differential equation. This one, oh no, pressed all the buttons. Okay, so what we're really going to look for first is some telltale signs. So we can see here that when y is equal to 0, wrong pen, y equals 0, our function will be undefined. And we know that when x is equal to 0, that means the numerator here will be 0. So it doesn't matter what happens on the bottom, so that will always have a slope of 0. Okay, so when x is equal to 0, it should be straight lines going the whole way across. So this is a possibility, this is a possibility, this one is not, and this one is not. Okay, the next thing that we're going to be looking for is we're just going to pick a point and determine which one is true. So if I pick a point in here when x equals -1 and when y equals -1, if it's this one here, I'll end up with a positive gradient. If it's this one here, I'll end up with a negative gradient. So let's go ahead and substitute those in. dy over dx is equal to -1 over 2 times -1 is equal to -1 over -2, meaning that it's just positive a half. So this one here is the positive gradient. So our answer is going to be D. Now question 7. Which of the following best describes an interval estimate of a population parameter? So the first one, the degree of uncertainty associated with the interval, but that doesn't have a lot to do with the population parameter. The easiest way to start this question is to go and Google interval estimate of a population parameter. So an interval estimate is defined by two numbers between which a population parameter is said to lie. So it's saying that for our interval estimate, the population parameter should be between those two numbers. So let's go back again and have a look at these. So the proportion of values, it's not really about the proportion. An interval that is calculated using the population parameter, well, kind of, but not really, because the population parameter should be between your two answers, meaning that D is our answer. So an interval that is likely to include an unknown value of the population parameter. That's our answer. Okay, so I believe that they've got the answer wrong to this question on the sheet. If you can figure out why I'm wrong, I'm all ears. But this is how I would solve this question. So, just double check that I am recording. Good. Okay, so W equals I times the conjugate of Z. So W is equal to I multiplied by, now if this is Z, the conjugate will be A minus BI. So now when I expand this bracket, I'll end up with AI minus BI squared is equal to AI, and then this will turn into -1, so we'll change it to plus B. So I'm looking for something that's got two positive components here for the real and the imaginary. So that would be this answer of B. Okay, so question 9. Now the trick with this one is when we're looking at these, I can see that if I have my little formula booklet next to me, this one, when I derive it, looks very similar to that one. And that's going to help me because it's going to knock some stuff out. So our first step for this is we're going to let U equal cos minus 1 x over 2. And we're going to use integration by substitution. So du over dx is going to be equal to -1 over root 2 squared minus x squared. Now, this is taken from the formula booklet, so just make sure that you've got that next to you while you're revising. Okay, so du over -1 over root 2 squared minus x squared is equal to dx. Now, when we have a fraction like this, it means that this part is going to be flipped to the top. So I can now express this as root 2 squared minus x squared When it's divided by -1, it means the negative will also come out to the front. du is equal to dx. Now, I'm going to put this into our function by letting u equal this. That means that my new function will become the integral, or the antiderivative of 1 over, this part hasn't changed, and now I'm going to put the next part in, which will just be u, because we've let this become u, and instead of writing dx, I'm going to write this. Okay, so now you can see that this part and this part are pretty much the same. So this one can cancel this one, and so that means that now I'm really integrating -1 over u with respect to u, which will become minus ln u, plus c. Don't forget Cody. Now the last thing that I need to do is replace this with this, so that now it's no longer in terms of u. Minus ln cos, or arc cos, plus 1, just like that. Now you'll see that that relates to A as our answer, so that's how we know that that's our answer. Okay, so if I look in my little formula booklet here at the formulas that I've got, I can see that there's something that's quite similar to this. Okay, so the formula that we're going to be using for this is the integral of A over a squared plus x squared is, with respect to dx, is equal to inverse tan x over a. Now in this case here, I can see that if I rewrite this, I can write it as 4 over 4 squared plus x squared, meaning that in this case a is equal to x. So when I integrate it, it's going to become tan inverse 1 x over 4. Okay, and now I can substitute in my two numbers of 2 and 0. So the next thing I'm going to do is pop those in. So tan inverse 1. Now when I put 2 there, that fraction will simplify down to be a half, minus tan inverse 1 of 0, which will simplify to just be 0. So that means that once I account for this turning into 0, I'm only left with this section, meaning that my answer is going to be B.